Welcome to Density Lesson 2. This is the second of 2 lessons on density. After completing this video, you are going to work on density practice problems that are listed on the website. To get us started off, let's do a density warm-up. First of all, take a minute to find the calculator button at the top right-hand side of your keyboard above the number pad. It is either a button with an illuminated calculator on it, or it is a greenish-blue glowing calculator symbol that you just push on the keyboard. Your job is to find the density of a shoe if its volume is 98 centimeters cubed and the mass is 300 grams. So to help you start this problem, I've given you 4 steps. Step 1, set up your problem. Step 2, solve your problem. Step 3, make sure you have the correct units in the correct places. And step 4, verify your answer. Please pause the video now and complete the problem. Press play when you are done after you have found the answer to the problem. Alright, you should have answered the question, finding the density of a shoe if its volume is 98 centimeters cubed and the mass is 300 grams. So for step 1, setting up the problem, you should have written density equals mass over volume. So taking our numbers from our equation, the mass is 300 grams, so I put it here. The volume is 98 centimeters cubed, so I put it there. The next step is to solve the problem. So you're going to take 300 grams and divide it by 98 centimeters cubed. And to show you how I did that, I'm going to take my calculator and move it on the screen, put it here so we can see everything. So I'm going to take 300 divided by 98 equals 3.06. So I get 3.06 grams per centimeter cubed. Step 3 is to make sure you have the correct units. Remember, density is mass over volume, so the mass unit, the grams, should be on top, and the volume unit, centimeters cubed, should be on the bottom of the ratio. Step 4 is to verify your answer. Double check your numbers, double check your problem. If you got 3.06 grams per centimeters cubed, congratulations, you can do a density problem. Lesson 2 notes are also going to be taken on ISN page 79. If necessary, please make a flip page to attach to ISN 79. Do not write on pages 78 or 80. So video guidelines. Watch the entire video once before writing anything down, and then watch the video a second time, pausing to write notes. Notes will be the underlined portions of the presentation. Remember, you can rewind the video to catch something you missed or to hear something again. Learning objectives. These are things that you should either understand or be able to do at the end of every lesson. So by the end of today's lesson, you should be able to complete these 3 objectives. Explain and calculate density, identify if a substance will sink or float when placed in another substance, and explain specific gravity. So let's do a quick check on the learning scale. Where are you right now? Can you explain what density is? Can you calculate density if I'm given the mass and volume of a substance? So if you were able to do the warm-up, then you are definitely a level 2. If you're a level 3, you can determine if an object will sink or float in another substance using specific gravity. And 4, can you calculate density if you are not given the mass and volume of a substance and you have to find that on your own? Most of us should be right here. We should be at a 2 or almost at a 2. So let's do a quick review from lesson 1. We know that mass is the amount of matter in an object. Volume is the amount of space that matter takes up. Density is the ratio of mass and volume. So mass divided by volume is what density is. All answers for density are always reported in grams per centimeter cubed. And density is important because we can use it to identify substances because each type of matter has a unique density. Density is like a fingerprint. There are no 2 substances or types of matter that have the exact same density. We also learned that specific gravity of a substance is the ratio of its density to the density of liquid water, which is 1.0 grams per centimeter cubed. So less dense objects float, and more dense objects sink. Now we have decided what density is, mass divided by volume, so let's talk about how we actually calculate that. Before calculating density, you must calculate both the mass and volume of an object. So we measure mass using grams on a balance, not a scale, because a scale measures weight, which is the gravitational force pulling down on us. A balance measures an already known mass with an unknown mass, and when they become balanced, that's how we know the mass of the new substance. We measure volume in three ways: length times width times height for regular solids, displacement for irregular solids, and a graduated cylinder looking at the meniscus or the lowest point of that curvature for liquids.